Did we ever find out where Oumuamua came from? Will there be a space station made of starships? And why is Venus rotating upside down compared to all the other planets? And in our free Q&A Plus version on Patreon, does life on Earth require the moon? Answering all these questions and more in this question show. It's time for the question show. Your questions, my answers. As always, wherever you are across my channel, the question pops in your brain. Just write it down. I'll gather them up and I will answer them here. All right, let's get into the questions. chrisreidburns. Is the next space station really based on Starship? What about artificial gravity using rotation? So there have been a bunch of ideas about how you could use starships as part of a space station. And I'm not sure the specific one that you're talking about, either to launch modules that would then be bolted together to form a space station. There's some cool ideas, like one where it's the same shape space station. So you start with the central hub and then you dock in parts and then the parts get bigger. And so you end up with this station that looks very symmetrical. So that's definitely possible. Actually launching and docking starships together. People have proposed that as well. Is this actually going to happen? Nobody is actually planning to do this. Nobody is putting in the kinds of money and investment involved to make this a reality. It is people who are drawing pictures, making presentations, thinking about it. Could you create artificial gravity with rotation? Sure. You could put two starships connected by a cable, have them spin around, and you would have artificial gravity inside your connected starships. Nobody's planning to do that right now. Rodney Allen, with the study of the path of Oumuamua, has it been calculated where this extrasolar asteroid came from? So the problem is that Oumuamua has been traveling for a long time, but in general, I think astronomers think it came from in the direction of the star Vega, which, if you're familiar with the summer triangle, it's one of the big bright stars in the sky. But the stars are moving. It would take Oumuamua 100,000 years to get the distance to Proxima Centauri. And it probably didn't come from a star that was as close as Proxima Centauri. It probably came from a star that was 10 times as far away as Proxima Centauri, maybe farther. And so it has probably been traveling in space for millions of years, and it could have come from anywhere because the positions of the stars change. If you came back 100,000 years from now and you looked at the stars in the sky, some of the constellations would look familiar, others would start to look pretty tweaked. And if you came back 1,000,000 years from now, the constellations would all look completely different. You wouldn't recognize any of the constellations in the sky because all the stars are moving. And so we can never know where Oumuamua came from. One interesting idea, though, is that Alpha Centauri, which is the closest star system with Proxima Centauri to the solar system, you've got two stars that are orbiting around each other. And that kind of orbital dynamics, as well as having Proxima Centauri involved with them, theoretically kicks objects out of its Kuiper belt and Oort cloud, sending a stream of material towards the solar system. And so we may very well find objects coming on trajectories where they clearly came from Alpha Centauri. And that's where we might recognize the source where these things were coming from. But no, Oumuamua, we'll never know where it came from unless we catch it and we study it and then we match the chemicals to, we'll never know. GortfromOort. How are globular clusters formed and why are they spherical? So the origin of globular clusters is still a bit of a mystery, but at this point, astronomers think they have most of the details nailed down. Now, globular clusters are some of the most incredible objects in astronomy. They're probably my favorites. They are millions of stars collected together into a very tightly packed ball. And you can see them in a small telescope, and it really looks like this ball of stars. And obviously, when you look at pictures from the Hubble Space Telescope, it's just mind-blowing. And where we are in the Milky Way, we are on average about 4 light years away from a star. But when you were inside a globular cluster, you are about 1 light year away from a star, and in all directions. And so you can just imagine how tightly packed your sky would be if you were on a planet inside one of these globular clusters. And so where do they come from? So there's a bunch of clues. One of the clues is that globular clusters are not part of the disk of the Milky Way. They are weirdly in the spherical halo that surrounds the Milky Way, that they are orbiting in strange directions and not just following the path of the stars that everything takes. And so that tells us that they probably have a different source where they came from. And when we look at other galaxies, we look at Andromeda, we look at M34, we look at all these other galaxies out there, we see similar globular clusters circling around them. And so the main theory is that they are what's left after a dwarf galaxy has fallen into a larger galaxy like the Milky Way, that at some point in the ancient past, a dwarf galaxy fell and was merged into the Milky Way. The Milky Way peeled off all of the stars around it, and you're left with the core of that galaxy. The Milky Way has a core at the center of it, but it's a large spiral galaxy. And so you can imagine that all of these individual globular clusters, and there are dozens of them surrounding the Milky Way, each one of those was a dwarf galaxy that came too close. And so, why are they spherical? Well, that once you have dismantled all of the outer parts of this dwarf galaxy, you're left with this central core that is a leftover sphere. And what's really cool about this is that all of the stars inside the globular cluster, and they're very old, they are 13 billion years old, 12 billion years old. These are some of the oldest structures in the universe, and they were formed when the original dwarf galaxy had formed. And what's really cool about these clusters is that all of the stars inside of it are orbiting around this common point of gravity inside, a common center of mass inside the globular cluster. And so they're all just going around in elliptical orbits, rising and falling inside this sphere that is orbiting around the Milky Way. They are really cool. There's I could go on all day about globular clusters. David McSween, has there ever been a wild out there NIAC grant that came to fruition like these amazing recent interviews of yours? So NIAC has been around for close to 20 years. This is NASA's Advanced Innovative Concepts Award. And this is where you've got, people pitch interesting out there next generation technology ideas to NASA. NASA gives, I think, $100,000-ish for a phase one where a person can go and explore the idea. And if they come back and the idea still seems viable, then they can get a couple $100,000 to go do a next version of it. And then if it still seems viable, then they can do a phase three, which can be upwards of $500,000. And then they graduate from the NIAC program. And examples of ideas that have graduated from the NIAC program are the solar gravitational lens by Slava Turyshev, or the star shade from various astronomers. So then it's up to, NIAC has done all they can. They have spent money to figure out if an idea is viable, that if there's any there, and then it's up to other people to decide if they're going to incorporate it into missions. But because the ideas are so out there, and the timelines have so far just been very short, no, I can't think of any that have completed the full cycle to actually being turned into a telescope or a mission or any of that. But I can see the DNA in ideas. There are ideas about in situ resource utilization on the moon. There are ideas about building radio telescopes on the far side of the moon. There's obviously the solar gravitational lens. There's the starshade concept that could fly with the Habitable Worlds Observatory. And so I think, if we 10 years, if we had this conversation again, then maybe there would start to be some of this technology would start to happen. But NASA and the space agencies are actually very risk prone, risk aware, risk intolerant. And that is because, if you are the principal investigator for a mission and your job is to find 10,000 exoplanets, you are going to choose the technology that is going to find 10,000 exoplanets. You want to do it with the minimum amount of technological uncertainty and risk in your project. You're going to go with whatever is safe, tried, and true. And for someone to go, this is great, but why don't we also put this wacky mushroom-based system into your telescope? And they'll be like, no, thank you. I just want, a Pentium and a chemical rocket. And so I think the gap so far is that there needs to be this next step where the things that graduate from NIAC then they have to be turned into missions in some way. That they've been proven viable enough that now it's a matter of investing and taking that risk. And that I think is the part that's missing right now. But hopefully, more of these ideas, as we continue to get the good word out, more of these ideas will be taken up and more of this stuff will eventually fly. It's time to shout out all the new $5 patrons. Jacob Sear Peterson, Richard Beyer, Esteban Duran, Sebastian Siva, Andrew Weidenheimer, Ronald Culmer, Gareth George, Paolo Nicosa, James Strait, and David D. If you want to join these names, join the club at patreon.com/universetoday. Brad Hoehne. Fraser, I do public outreach programs in astronomy. How do you think that we can best impart the importance of spending money as a society on astronomy, specifically, and science more broadly? I mean, it's really hard to make the case that spending money on science in any one specific industry or one field is the important thing to do. But all you can do is point at the wonders of our modern society and all of the incredible things that we have accomplished, that we are able to communicate at the speed of light across planet Earth, that we are able to, we have satellites orbiting around the Earth, that we can watch our weather, we can predict the weather into the future, we are building artificial intelligence, that we have the modern health that we do. All of this stuff all stems from basic scientific research, that people just have questions about the nature of reality. Wherever there is a question, people are trying to understand it better. And that over time, with continued investment on a broad range of science, we have the society that we have today. And that any nation, any group that chooses to stop investing in science will stagnate. And that's, we just know that's what happens. So it's really hard to make the case to a person that science is great. But I think that, I would use analogies about how, there are things that we are curious about, that we want to know the answer. And that because people were curious about those things in the past and found the answers, that our lives have been made better by those things. And that we don't know which are the things which are going to turn out to be the ones that make our lives better, but our lives have been made better. So it's a tricky job. Science is cool. And for me, as an atheist, it is the closest thing that I have to spirituality. That you're investigating the unknown. You are opening yourself up to the mystery of the cosmos. I know this sounds really woo-woo. And there is this feeling that we get as we explore, as we seek mysteries and then make progress towards understanding them better. That is very satisfying. And it has always hit me at an emotional level. And I think that there are some people that that's the case for them. That you feel these feelings about how we make these discoveries, and it hits you at an emotional level. And for some people, that's going to resonate, and for other people, it's not. They just don't care, right? What has science done for me lately? And I don't know if there's any convincing them. So I think for me, I spend my time interacting with the people who are already convinced. I'm preaching to the choir. I'm not here to convince you that science is great. I'm not here to convince you that astronomy is interesting, that space exploration is cool, that planetary science is fascinating, that cosmology will fill you with a sense of wonder. I'm here to connect with you on this thing that we all agree on. And so I would be more interested in sharing the enthusiasm with the people who already feel that way. And don't worry about trying to convince other people. But that's just me. Mufasa Putasa. Is there a consensus, or at least a convincing explanation, as to why Venus rotates on its axis in a different direction than all the other planets? Perhaps its axis is shifted almost 180 degrees. So yes, Venus is upside down. It rotates in the direction that is opposite from the rest of the planets in the solar system. And so something happened to Venus. What happened to Venus? Well, there's a few viable possibilities. One is that it just rolled over, that without a large moon to stabilize its axial tilt, it just rolled over upside down. We see Neptune. Neptune rolled over. Maybe, it's at 90 degrees, not 180 degrees, but still, maybe something happened like that. The other possibility is that something very large smashed into Venus and rolled it over. And we know that something very large smashed into the Earth in its ancient history, and that's what gave us the moon. So it's possible that that happened. And then the other possibility is that you had migration, that Venus, Earth, Mercury, various planets, they migrated inward, outward, and as they migrated, they went through various belts, did gravitational interactions with other planets, and that caused it to roll over upside down. So it's a pretty weird thing every part of Venus is bizarre, but that's one of the things that you can add to the list of weird things about Venus. SeaHorseOo, would you agree that we should give up on looking for extraterrestrial life on Jupiter's moon and orient our curiosity towards more terraforming development? It's been long enough. Absolutely not. We have not even begun to search for life on the moons of Jupiter. We have 2 spacecraft that are going to Jupiter's moons right now, the Europa Clipper and the European Space Agency's JUICE mission. And neither of them are really equipped to search for life on Europa. They're going to be able to image the surface of Europa and Callisto and Ganymede and give us a much better understanding of what those moons look like. They're going to hopefully be able to detect the presence of geysers that could then be sampled in the future. And then you could imagine some follow-on mission that is a lander to go to Europa, and it lands near one of these geysers, if they exist, and attempts to sample that material to find out if there's life there. And then you can imagine some future mission where it lands on the surface of Europa and then it melts down through the ice to reach the water below, and then try to scan the water, the sub-ocean on Europa for any kind of evidence of life. But nobody has done anything that is actually searching for life on any of these places. And what is terraforming? I don't know how you terraform Europa. What is that? The way you terraform Europa is you wait for the sun to turn into a red giant, and then Europa melts. Now it's in the habitable zone, which would be really cool, by the way. But there's really only 1-2 places that we could potentially terraform: Mars and Venus, and the moon that I mentioned many times before. And that's a very long, hard, complicated work. And if we attempted to do that, then we would destroy any evidence of life on any of those places. Obviously not the moon, but Mars, Venus. So no. And we are not technologically capable of doing any of those things. So no, now is the time that we search the solar system for evidence of life. Now is not the time that we attempt to terraform all of the places in the solar system. Did you know that you can watch the same video for free with no ads and get a bonus question over on Patreon? We call that Q&A Plus. And this week's bonus question: did the Earth need the moon for life? And I'll put a link in the show notes so you can access that episode directly. All right, those are all the questions that we have this episode. Thank you, everyone who asked your questions in the YouTube comments, as well as everybody who joined me for the live show and asked all of the questions there. Now, this show is 2 hours long. I have no idea what the questions are going to be, and yet it's a lot of fun. Hundreds of people show up, and then we sort of chop that up, and that's what becomes these question shows. But if you want to be able to participate, we'll put a link to the next one, an upcoming event here on the channel. They rotate, so sometimes it's in evening in North America, sometimes it's the evening in Europe, and sometimes it's in the evening in Australia and Asia. So we'll put a link to when the next one is going to be. Now, I'm going to talk about some more shows that I've been watching, but first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrew M. Gross, Braley Roofing, Brian Bodie, Carradwin, Chuck Hawkins, Commander Bayluck, Cy Nielsen, David Gilton, David Matz, Dustin Cable, Evan Pro, Greg Feely, Hans Schultz, Hudson Ward, Jay Graves, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Marcel Smits, Michael Purcell, Modso, Paul Roebuck, Ren Kaidu, Robeck, Sean Sargent, Stanislav Rajev, Stephen Fowler-Manley, Thomas Skadron, Vlad Chiplin, and Wolfgang Klux, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So there's been a bumper crop of science fiction and anime shows that I've been watching, and man, it's such a good time for television. So first up, we got a new season of Black Mirror, season 7. And, you know, as always, there are hits and there are misses. Some of the episodes of this Black Mirror were terrific, a little unsettling as always. Others were, not that great. But there's a sequel to the USS Callister. And so if you remember, that was where a bunch of people are cloned and put into a video game and sort of made to be the stars of a video game. But anyway, and so if you remember that, there's the sequel to that. But I recommend, like, what my wife and I did was we went back and we watched the original one in season 4, and then this is the sequel. You can see all of the callbacks and all of the connecting tissue between the two episodes. So if you sort of, as you get deeper into Black Mirror, definitely do that. The next show that just returned is Last of Us, and I haven't even watched it yet. I'm going to go watch it like right after I finish this. So no spoilers, please. But yeah, season 2 of The Last of Us has come out. The next one that's coming out very soon is a new season of Love, Death, and Robots. And I think this is my favorite television show ever. And this is actually a bunch of short animated shows on Netflix where they've taken like various science fiction short stories and turned them into animated versions. And they're so good. And there's like, I think 3 seasons. I think this is season 4. And like every time a new season of Love, Death, and Robots comes out, like we just watch them. We just mainline them. That's it. That's all we do for the whole evening. However long it takes, that's what we watch. And they're really good. So if you haven't watched Love, Death, and Robots, I highly recommend it. And I'm really looking forward to the next season. It should be out very soon. And then a couple of other shows are coming very soon, but you may want to get caught up on them. One is Andor, which we're going to see season 2, and I guess the final season of that. And the other one is going to be on Apple Plus, and that is the Murderbot Diaries, which is an adaptation of a fairly famous science fiction book series. So there's a lot of good stuff coming in science fiction, anime, fantasy, and so on. All right, we will see you next time.